Hello everyone, my name is Mamduh Bakr and I am studying at University of Turkish Aeronautical Association. Today, me and my partner Gali are going to discuss about a captivating topic which is about glider soaring via reinforcement learning in the field. So, in this video we are going to into detail about how it works autonomously and what is the meaning of the reinforcement learning and what is the important things in this article. By the way, what is the meaning of gliding itself?
It is an activity where the pilots fly unpowered aircraft, known as gliders, using naturally occurring currents of rising air in the atmosphere to remain airborne. But in this research, we will only focus on autonomous gliders. Autonomous is unmanned, right? Isn't it?
Yes, autonomous gliders, that means unmanned gliders use. There is a song, Fly Like an Eagle. These words made some scientists to think about it, especially when it comes to soaring birds, like eagle, who seem to reach high altitude. Scientists understand that the upward currents of warm air assist the birds in their flight, but they don't know how birds find and navigate these thermal problems.
Yes, it's still a mystery how the birds find out hot rising pockets of air and use the currents to stay aloft. As I read, they use reinforcement learning for the gliders to be able to navigate an uncertain environment and atmospheric channels. Is it so?
Yes, it is. Nowadays, all gliders learn to fly using air currents. Just like a bird, one of the methods to learn it is reinforcement learning, to teach gliders to fly by using thermals.
This is what the birds did, using thermal plums or soaring. So reinforcement learning itself, it's learning by environment to figure out about the behavior of the environment.
Yes, brother. Actually, this is a training tool that works like trial and error. The system is given a number of inputs and it's asked to act in a way that maximizes a certain reward.
So it starts without any knowledge of the task and it learns how to behave correctly over time.
In this case, the input consists of flight information like glider's pitch, yaw, ground speed, etc.
At the end, then the reward will be to maximize its climb rate or the speed which it gained high.
I think future autonomous aircraft could take advantage of thermal rather than relying on noisy and energy-intensive powered flight. It is also suggests that all might be able to help us figure out exactly how soaring birds do what they do so well.
Yes, it could be, but to be able to do that, it will take several days to train the glider, or maybe more due to inconsistency of the wind velocity. When training their algorithms, the scientists found the same factors, particularly vertical wind acceleration and side-to-side torque, were important when teaching the system's gliders to navigate smoothly. These two as effective mechanistic cues.
The researchers trained their algorithms first in a simulator and then in real life. They performed many flights in the skies over California, which lasted on average about 3 minutes. They steered their glider to a fixed location using manual control, and then the artificial intelligence took over. Using their currents from thermals, which can travel as fast several meters a second, to climb into the sky.
One of the authors mentioned, in a good situation, the glider could stay aloft for about 45 minutes, and we had some flights where the wind was too strong for the gliders to handle, and we had to get it back prematurely. Also, we had a few with eagles attacking the gliders.
Wait a minute, you said about mechasensory. What is that?
It is a sensor which can sense a movement or vibrator. Because of this one can guide soaring. This sensor can detect vertical acceleration. Can detect the vertical wind acceleration, the spatial gradients in the vertical wind velocity across the wings of the gliders, and etc.
Now it's better to move to discuss the methods of archery. I read about spatial gradients in the vertical wind velocity induce a roll-wise torque of the plane.
That is right, because when there is vertical wind, it will cause a roll-wise torque. There are three sources which cause roll-wise torque. One, the feedback control of the plane, which enable the system to adjust its performance to meet desired output response. Two, spatial gradients in the wind, including turbulent fluctuations. It is obviously true by imaging it. And the last one, roll-wise moments due to various aerodynamic effects, such as the Hadra effects, and then trim effects, overbanking effect, etc.
I understand now.
I have one question about wingspan. Where most of the glider have huge aspect ratio, their span is lengthy and or extensive compared to their width, and how it behaves with a current.
As I know, this is because drag created during the production of the lift, known as induced drag, can account for significant portion of the total drag on a glider. One way to increase the efficiency of a wing is to increase its aspect ratio. Glider wingspan are very long and thin, which makes them efficient. They produce less drag for the amount of lift they generate. Glider, which has, let's say, 2 meters of wingspan, in effect teaches itself how to fly by evaluating each variation in air currents and receiving a reward for every correct decisions that resulted in increased altitude.
So I guess why all the planes don't have wings with huge aspect ratio. First, not all the design for efficiency flight. Military fighters, for example, are designed with speed and maneuverability well ahead of efficiency. Another reason is there are limits to how long and skinny of a wing can get before it is no longer able to carry the required loads. It can be concluded that it wouldn't be difficult to create autonomous gliders that use artificial intelligence to navigate thermals over long distances. The glider had learned to optimize its position and developed a strategy to catch the warm-up droughts. We find it is very impressive as the glider had no prior knowledge about atmospheric physics or aerodynamics. Looking forward to doing this in the future, such craft could be used for enduring scientific surveys and for ambitious projects. By learning how to fly like a bird, we can learn more about their lives as well.